Hi, so in this video we're going to take a look at how we can create decorators that can take optional arguments and then be called with or without the parentheses, much like, for example, the LRU cache decorator that's in the standard Python library. If you look at LRU cache, you can use it in these two forms. You can just use LRU cache, and then you can basically set up this cache for your function. And I'll explain later what LRU cache does if you're not aware of it or if you're a little rusty on it. But essentially this creates a cache with a default size of 128. Now on the other hand, if you want to override that maximum size, you just specify an argument. So now you're using this LRU cache decorator but with parentheses and then passing an argument to it. And you still end up with a cached function. So I'm going to assume that you already know what closures and decorators are and how to create simple decorators. I will review this now in this video, but if you already know all that stuff, just go ahead and skip it and go to the next section called Decorator Arguments, where we're going to talk about decorator factories. This is just basically a quick recap of simple decorators. So we're going to do one which is kind of my go-to example for decorators, which is to basically time how long a function runs. So I'm going to need perf counter from that. So from time, I'm going to import perf counter, and then I'm going to create my decorator. So my decorator is going to be called timer. It's going to decorate a function. Then we're going to create our inner function, which is going to basically allow any kind of arguments being passed to it, positional and or keyword only. Then we're going to say start equals perf counter, so that we're going to probe the perf counter. We're going to call the original function with whatever the arguments are, like so. Then we're going to end, so we're going to set end to, again, we're going to probe the perf counter once more, so now we'll know how long it took. So now we go ahead and print, and of course in real life you might actually log this somewhere. You may not want your production code to print something as it's running, or you might, I mean that's fine, whatever. So I'm going to want to recover the name of the function because I want that in the print statement, and then I'm going to print end minus start, and I will give that a format. And we'll say, let's say 0.5f. So I want 5 digits after the decimal point. And let's specify specifically that this is in seconds. And then, of course, I want to return the result of calling my original function. That's how a decorator usually works. And then, of course, I need to return this decorated function. Okay? So this is now our decorator. And we can decorate any function we want. So let's go ahead and do an example from import. I'm going to import random. Then from time, we're going to import sleep. And then I'm going to time a function. I'm going to call timer. I'm going to decorate with timer, which is really a function call. I'll show you that in a sec. And then I'm going to decorate my function here, which is going to require one positional argument. Then that's it. So only one positional argument will be allowed. And then I'm going to mandate a keyword only or a name only parameter. And let's go ahead and say sleep random. So I'm going to sleep a random amount of time. And then I'm going to return a times b. And I'm doing the sleep simply because otherwise this thing here is going to be so small that we'll probably just see zeros. Okay, so now that we've decorated this function, we can call the decorated function. Now, what is my func? Well, it's no longer this original function, right? It's the inner function that was returned when we decorated with timer. So if I call my func, I can say my func, and let's say we'll do a star, and then we'll set b equal to 20, like so. Then you can see I get the result of my function, my original function. But of course, because I decorated it, it's now actually running inner, which means it did the timing as well, and it ended up printing the name of the function and then how long it took to run. So remember that this @ symbol here is really just syntactic sugar. We could easily have decorated our function this way as well. We could have just taken the function, written it normally like so, And then to decorate it, we would basically reset what myfunc points to. So right now, at this point in the code, we have a variable called myfunc that points to a function object. Now I'm going to redefine what myfunc points to. And it's going to point to the result of calling timer, passing it myfunc, right? That's how decorators work. And that's what that syntax really is all about. So a decorator is nothing more than a function that receives a function as an argument, the decorated function, modifies the function's behavior in some way, and returns the modified function. Now usually we modify the behavior of the function by adding code before or after calling the original function, and then returning the value of the original function call, or maybe modifying the return value before actually finally returning it out of our decorator. But there is one small issue. The decorated myfunc function is no longer the original one, and we lose some of its metadata. Let me show you what I mean. Let's go ahead and take the same function again. And we're going to add a docstring, for example. So triple quotes and then a docstring annotation, like so. So now if I look, there's certain properties I can look up on myfunc. I can look up its name property, which is myfunc. And now of course I can also look up its docstring property, like so. And I get the docstring annotation. Now let's go ahead and decorate it. So here I'll decorate it using the long way. I won't use the syntactical sugar. It would do exactly the same thing, but I'm going to pass it now to timer. And we'll pass myfunc, like so. And of course, I've got to type correctly. Now, if I look at myfunc done the name, you'll see that I no longer see myfunc. And then same thing with the docstring, that suddenly disappeared. Okay, and that, of course that makes sense, because what are we running? What is myfunc actually now? It is basically this timer function, right? And well, it's the result of the timer function, which is the inner function that gets returned from the decorator. So that makes sense that our function name is actually inner, and we have no docstring because, well, we have no docstring specified here. If we did, we'd see that docstring show up. If you want, we could say this is the inner returned decorator function, or decorated function, like so. So if we were to do that, and I was to run through this code all over again, you see my original myfunc, my original docstring annotation. Now I decorate it, my name is inner, and the docstring is now that docstring over there. So as you can see, those were replaced by the name and docstring of the inner function. And of course, since it is equivalent, the same thing happens if we use the @decorator syntax. That's not going to change. If we go back and use this syntax over here, which is exactly the same thing, then you'll see that myfunc's name, myfunc done the name is inner, and of course myfunc done the doc is the inner decorated function's docstring. So to work our way around that, there is another tool that's called the wraps decorator, which is also in the func tools module. And that basically helps move some of this metadata from the original function we're decorating to the actual decorated function that's being returned by the decorator. We could do this manually, but wraps just takes care of all those details for us. So from func tools, we're going to import wraps. And it's always therefore a good idea to use wraps when you're creating decorators. Don't skip that, because it really makes debugging a lot simpler if you know that, the function that caused the problem wasn't inner, but was actually myfunc. Now, maybe it was the decorated myfunc function, but at least you know where to start looking. Here, if you use this timer all over the place, you'll get an error that will tell you, oh, it's inner. Well, it could be inner in, 12 different places. So you really want to use wraps. And it's very, very simple. I'm going to take the code from here again. We're just going to copy paste it. So now I've got the wraps. All I need to do is I need to say @wraps, and I do need to tell it which function it's wrapping, which we know because that's what the timer gets called with. And now we can redo our decorated function, and Let me grab the one that had the docstring, this one. So we'll take our function. We can decorate it with the at syntax, so at timer. And if we now look at myfunc done the name, you'll see we have the correct name, which is myfunc. And if we look at myfunc done the doc, then for the docstring, we have the original docstring annotation. And of course, it would work the same way if you used the long way of doing it by first defining the function, like so, and then go and redefine what myfunc is, which is timer of myfunc. And I'll let you look at the properties, name and doc for that function yourself. Okay, so this is a quick recap of how we create and use decorators in Python. So now let's take a look at what this video is actually about, which is creating decorator arguments. Because the decorator here that we've used, this timer, doesn't allow the possibility of passing arguments to the decorating function itself. And if you look, as I mentioned right in the beginning, at some built-in decorators in Python, you'll notice that some decorators are parameterized. For example, the LRU cache decorator in the functools module, as I showed you. I'm not going to go over this here, but if you look at the Jupyter Notebook that's available in the repo, it's linked in the description below the video, then I show you an example of how the LRU cache decorator works and how you can call it using these two different kind of syntaxes that I had showed you right in the beginning. But I want to get into the details of what LRU cache is. You can read that up. I've got that in the notebook. Our aim is to basically achieve a similar result with our own decorators. So how are we going to pass an argument to our decorator? Because our regular decorator expects the function that's supposed to be decorated, not an argument, right? So in order to do that, we have to create what's called a decorator factory. And it is going to be a function that is going to take in that parameter, and then it's going to create and return a decorator function, hence the term decorator factory. Let's do a simple example of this. Let's go ahead and let's go back to our timer example. Somehow, we not only want to output the function name and the runtime of the function, but we also want to provide maybe some form of categorization that we want included in the output. Maybe we're writing these timings to a database, and it would be helpful to group timings of different functions into various categories. So let's go ahead and do that. So we're going to create this timer function that's going to take in a category, okay? And we're going to, let's say, set the default category to null. Now, this is not a decorator. This is not taking in a function and returning a function. This is just a function that takes in an argument that is not a function. So not quite a decorator yet. What we're going to do here is we're going to create a decorator function inside this function. And so it's a decorator. It will need to take in some function as an argument. Then I'm going to use the wraps, just like we did before. And I'm going to def my inner, and then we'll have, just like before, basically the same code as before. And I'll just go copy paste it. Will be easier. So we'll take this and we'll need that. And so what I'm going to do here is I have this additional category, right? So I'm going to use that here. I'm going to say category like so. Now, this inner is going to return the result. This is the decorator function, so that needs to return inner, just like before, no different. But the difference here now, finally, is that this timer function is going to return the decorator. So it's going to return the decorator. So you can see timer itself is not a decorator. It is just a function that, when called, will return a decorator function. Let me fix my typos. So in order to use timer now as a decorator, we have to call it to get a decorator function. And that return value can then be used as the decorator in the usual way. So let's break it down. Let's say that I'm going to create this function, dec timer, section 1. Basically, it's going to be the return value of calling the timer function with section 1 as, let's say, the argument, right? So this timer, remember, returns a decorator. So what we get back from timer is a function that we can then use as a decorator. Now I'm going to create my function again, def myfunc, and I'm just going to copy paste it from somewhere. There we go, from here. So now I've got my function, right? Just like before. But what I'm going to do is I'm going to now decorate it. So instead of using the @ syntax like I would before, I'm just going to use the long syntax first, right? And I'm going to take this dec timer section 1 and I'm going to pass it myfunc. So what did I do? I built a decorator by calling the timer function. That is essentially a decorator factory. It returns a decorator. And now I can apply that returned decorator to myfunc, like so. And now I can go ahead and call myfunc. And we can say, let's say myfunc5 and then b equals 100, right? So as you can see, we now have the section name because that's what happened when we created our decorator. Our decorator basically became itself, right? It was a closure. It closed over category because we're referring to category over here. So inner is a closure that basically captured category and then function as well. So when we do that, we get the result back from the function and we now get this over here. Now, of course, we don't have to write it the long way. What do? Well, we would actually write it like so. In practice, we would use the @ symbol. So we're going to do @timer, but now I have to call timer to pass it an argument. And so I'm going to pass it, let's say, section 2, like so. And now if I call myfunc with 5 and then b equal to 20, you'll see that I get section 2, myfunc, the name, the number of seconds, and then the actual result of multiplying these two values. Now, what happens if we do not provide a section? Well, we defined a default, right? If we go back over here, we provided a default for this thing. So that's perfectly fine. We can now go ahead maybe and say, well, I don't want a section for this thing. I want it to be, let's say we're saving it to a database. I want the category value in the database column, in the database field, to be null. And so I can do that. I can call now myfunc, let's say 10, and then b equals 100. And as you can see, we get null for the category and that. So we are able to basically call timer without an argument when we decorate myfunc. But that syntax is a bit awkward. We have to remember to use this all the time if we do not want to actually pass a value. And therefore, the reason why I provided a default value in that timer function. If we think back to the LRU cache decorator we looked earlier, well, we saw that we could call this LRU cache with or without. You could decorate a function with LRU cache where LRU cache was used with or without the parentheses. If you use it without a parentheses, it's going to default to a size of 128. Otherwise, you can override that and set whatever you want. You can even make it unlimited by specifically setting max size equals none. So how can we achieve the same thing with our own decorator? So at this point, this is really just to make calling the decorator, making that syntax just a little simpler. We're going to do some work so that we can call timer without using the parentheses or using the parentheses and passing an argument, right? So we want to be able to achieve both those things. Do you need to in your code? No, it's just basically something that makes it a little nicer when someone is using your decorator. So to do this, let's deconstruct the decorator syntax first to see what's going on. So here are the two examples, right? This is what we want to do. I'm just going to copy paste that from the notebook. So this is the first variant that we want for using our timer, and this is the second variant that we want to be able to use for our timer. So in the first variant, there's no arguments and no call, right? We're not calling anything. So we want to be able to basically, if we were to write this as code, and I'm not going to run this actual code yet because we don't have anything written to support that, but I'd want to be able to say def myfunc, let's say a comma b, return a times b, and then we'd want to do decorate it like so, right? I'm now using the long way of doing it. Myfunc, like so. So that would be the first variant of how we want to be able to use this code over here. And if you want to make it look like Python syntax coloring, you can just type it that way. Now in the second variant, however, we want the behavior to be different. Here, I want to be able to call timer with just my func. In the second one, I want to be able to do the following. So let's go ahead here, and I want to be able to say my func equals timer section 1, call that, and then apply the result of that to my func, right? So this is the two variants that we're looking at doing, these two over here. Now, as you can see, in the first variant, the argument received by timer will be the function we want to decorate. In the second variant, it will be the category string. So our decorator factory is going to need to differentiate between these two states and modify what it actually returns. In this case, where we actually have a function as our first argument, we just want to return the decorated function. In the case where we have, let's say, a string and not a function, we want to return the decorator that's going to be used to then decorate my func. So we're going to use the built-in function callable to determine if that argument is a function, which is the first variant, or a string in the second variant. So let's go ahead and write that code. So let's call this timer just like before. And now my variable is going to be, I'm going to give it a more meaningful name. It's going to be func or category. I don't know which one it's going to be. I'm going to default that to none. And now let me go ahead and write the decorator. So the decorator is going to take in a function, and then we're going to do just like before. Basically, we're going to use wraps and then def inner. So nothing changes here. This is all the same code. And actually, I'm just going to go copy paste it so I don't have to retype everything. So basically, I'm going to take this over here, right? So this is the decorator. So I am defining my decorator here inside my timer function, just like before. Nothing's changed. What changes is what needs to be returned from this decorator factory. And so I'm going to test. I'm going to see if callable func or category. So if that variable was a function, what do I want to do? Well, a callable was passed in. So this is the first variant, right? So basically my function is equal to my function or category. I'm just going to break it out this way so it's actually a little bit more straight. You know, we can break this out just to make it very explicit what's going on. So in this first instance, I have my function is my parameter that was passed into timer, and my category, I'm going to default that to null. If that wasn't the case, right, otherwise, and here I'm going to make sure that it was a string, for example. So I'm expecting a string, right, in my function or category. If it's a category, it's not a function, it's got to be the category, should be a string. I'm going to make sure of that. So if that, or it was passed in as none, I'll accept taking a call to timer where the func or category was not even passed in. But in that case, I'm going to assume this should be the null category, right? So I'm going to go ahead and say the category equals func or category or the null string or the string null. And this or just says, well, if func or category is none, put in null. If it's already specified as a non, falsy value, a non-empty string, then use that. Now, what do I need to do? And then otherwise, let's just go ahead and just do that clause first. Then we're going to raise a value error. So I'm just adding a little bit of exception handling over here. So expected argument to be a string, a callable, or none. Okay, and let's capitalize none since it's the actual none. Okay, let's fix that typo. But we're not done, right? We need to return something from this, and this is where it's going to happen. If it's a callable, what are we going to return? So if our argument that was passed in, this is variant number 1, if that was the case for variant number 1, we didn't actually use for this variant over here, we didn't actually use a call, right? So basically, what's timer receiving? It's receiving my func. So if that's the case, I want to return the decorator itself that I actually want to use. So I'm going to return decorator. But of course, I cannot just return decorator. I need to tell it what function. So I'm going to pass it this func over here. So basically, I'm going to decorate, right? I'm going to call decorator with this function. It's going to return the decorated function. That's what I've done here. And that's exactly what I want in the first instance. When I basically decorate my func with timer, I want to have basically the result being what? Being the decorated function, as we can see here, probably better using the long way of doing it. And then in the case where I have the category, well, I don't want that. What I want to do is I want to return the decorator function now, not the decorated function, but the decorator function itself. So I'm going to return decorator, but I'm not going to call it because I need to return the decorator function, not the decorated function. But moreover, it needs to know about this category, right? And this is why I set category over here and category over there, because this decorator here needs to know the category. So I'm specifying that in my outer function. Those are closures. They're going to basically include category in the actual closure, the decorator in a function. Okay, so as you can see, this wasn't too bad, right? If you think about what our original one was, it was this. And basically, this is pretty much the same approach you would use for any kind of decorator where you want to be able to call it with the parentheses or without the parentheses. You just have to differentiate between the two cases. I know there's other ways of doing it as well, but I find this one to be the most straightforward. So let's go ahead and else if, and we could say elif actually, elif. Okay. So let's give it a try. Let's say I'm going to decorate and I'm going to use section 1 and I'm going to decorate my func a comma b, and we'll just return a times b. I'm not going to worry about the timing thing, but making it sleep for a bit. Let's go ahead and look at my func dot name. Let's see what we have. Well, it's my func. That's correct. And then if we call my func, let's say 2 and 3, we get a result of 6, and we get our expected output here from the decorator, from that print function. On the other hand, I can also call it just using timer. So I'm not going to specify a category, and I'm not going to specify the parentheses. I could if I wanted to. I could do that. Let's go ahead and make sure that that still works. So if we do that, and then I look at my func done the name, you'll see that we have my func, that's the name. Again, that's correct. And then I can call my func with 2 and 3. I get 6 and I get this null over here. But now the additional nice thing is that I can do this without having this awkward looking, empty call syntax. And I've got an error over here. Let's go back. I can see already what that is. So in line 13 there, func or, func underscore category should have been func underscore or category, because that was what we passed into it. So let's go back and fix that quickly. And func or category like this. We can run everything else again. All right, let's decorate our function. Let's look again at the name property. Let's make sure that that is still showing correctly. Yes, it's showing as my func. I can now call my func 2.3, and as you can see, it works exactly the same as if I had called it with just the empty parentheses. It defaults to null. I get the name of the function, and I get the runtime of the function, and I also get the actual result. So as you can see, we achieved a cleaner syntax, and the code to do so is not particularly overcomplicated, and you can basically reuse this pattern all over the place when you're writing decorators like that, when you want to provide decorators that may or may not take arguments, and in the case where they don't, you want to be able to call it without the parentheses. You can use the same pattern. So you just remember this one time and you're good. So is it worth the trouble? Well, that's entirely up to you. My take on it is yes, it's absolutely worth the trouble. It makes the code that the users of my decorator have to use, I think, cleaner. I can tell them you can use the decorator this way, or you can use the decorator this way, and they're not forced to do this every time. Ultimately, that's up to you. Thanks for watching.